theory 10 years analysis. Yeah, online students, if you have a question for me, do check in accordingly. But again, I'll try to be smooth. All right, unless it's very, very urgent questions, then type it in. If I miss it, then during the break, I'll address it. All right, now, ready? Everyone should have seen this before. In case your teacher never print it out or never showed it before, all right, you got to, because sometimes some schools teach extra. So the extra is, to me, not important. I need to know what I am being tested on, according to Singapore Examination and Assessment Board, SEAB. So this is what I put it up. That's why I need to give credit. Practical assessments and requirements, all right, from them. So here we go. Basically tell you what they will test you on. So I want to know, because I want to have clarity and confidence when I walk into the practical lab. So candidates should be able to perform a range of experiment techniques, okay? So you know and I know. Titration, okay? Acid-base titration. So titration, let me go broad-base first. Speed of reaction. All right, what else? 3, experiments involving separation techniques. 4, salt preparation. 5, gas collection. 6, this is your redox, I believe. Test for oxidizing and reducing agent. And also displacement reactions. Displacement, got what kind of displacement reactions? There are 2 types of displacement reaction, I suppose. One is called your halogen displacement reaction. I want to know what they want to test me. Halogen displacement reaction. Second, metals displacement reaction. So I want to make sure that before I walk into the exam, the lab itself, I want to be very clear. Okay, I know this pretty well. All right, I know what's happening. Okay, and what else? You need to know, obviously, your QA, your test for cation, anion, and gases. So this collective known as, which is stated here. All right, notes for QA. Okay, so later we enter a bit more. All right, I just want to go broad base first. And number 7, all right, in terms of organic chemistry. Now, how many of you have done a practical on organic chem? No, organic chem very big, right? How many of you? Have you done polymerization before? No, because the monomers there, to be honest with you, cannot smell it. Smell already, it's toxic one, most of the monomers. It won't do this. All right, we'll do esterification, not easy to do. They won't ask you to do, I don't think so. It's very difficult to get the ester out. All right, so organic analysis will seldom come on, the organic compound. So you must be aware of all this. In case you're not, welcome to the workshop 101. Okay, but you may be given very simple one like this. All right, indicating the presence of unsaturation, like alkene CC double bond. They may be set, although I never seen it before at your level. Okay, it could be a 2-3 question hiding somewhere in the theory part. I'm not sure. Haven't seen it ever, but this has been there for the longest one. All right, and you also need to know what? You need to know your use of data loggers. How many of you in your school use data logger with a pH meter, pH probe before? Anyone? Data logger. So it's a computer screen. Normally the school quite rich, they can use one. Don't they, right? In case you go see before. It's just the number you jump on. The data logger can be attached to a pH meter, a conductivity meter, can be attached to a lot of things. Because this is expensive. How can one student have one set? Why did you put it there? Were you aware? Because it can come out with where? Planning. The theory. Yes? So it come out in the planning. May include the use of data loggers. Okay? All right. So I'm going to move back a bit here. All right. Is there anything I want to catch from here? Obviously, things what they say with test one. So as I run through, ask yourself, are you familiar with them? That's what I want you to do. Let me make it even bigger. Can I? Oh, this is good. Number 1, Okay, here we go. Okay, the titration portion. Ladies and gentlemen, SEAB, what is in charge of your school and therefore in charge of you? Say you need to know the following acid-base titrations. And in acid-base titrations, meaning acid and alkali titrations, you are supposed to know these are the few indicators that will only come out by right. All right. Suitable indicators. You usually see is always these three. Methyl orange, screen methyl orange, thymophthalin. Used to be phenolphthalein. Phenolphthalein, we pronounce properly. But it has been known to be carcinogenic a few years back. So they have been removed from the O levels and IP syllabus. In A levels, you still have. That's the problem. Okay? When you go there, then you handle them accordingly because they're more mature. If not, they causes cancer. So they have removed it already from the syllabus. So these three will be taken a look later. All right. Now, besides acid-base titration, there are other types of titration that may also be required when appropriate, and sufficient working details will be given. So they'll tell you what to do. Because by right, you're only familiar with acid-base titration. Sodium hydroxide, hydrochloric acid, for example. You know it very well. But they say, could have other type. May I know what other types? Ladies and gentlemen, this is how we prepare for practical theory. In case you don't know. Because I want to know what I need to know. Anyone? What other types of titration? Sorry? Very good. Ladies and gentlemen, write it down. It could be redox titrations. What is redox titration? We'll later run through a little bit, all right? With some question. Redox titration means reducing agent and oxidizing agent. Wow. So you have, instead of acid and alkali, okay, let me write it here. You have a reducing agent, react with an oxidizing agent. Okay, like that. Short form can O and R. Can. So these are the two reactants, one in the burette, one in conical flux. So besides acid base, besides redox, what others do I have? What else could it be? Anyone? It could also be acid. Now remember titration, I need what? First, let's appreciate the word titration. It's always back to the theory, you see. Titration always got this thing there, that she down. Yes? Later we're going to draw this many, many times. And it's definitely going to have a conical flux. Make sense? Bare minimum. Right now. Must have this thing. So key thing is in titration, this thing must flow. This thing that's below, use a different color, must also flow. They must be equal. Make sense? So very easy for me to guess one. What else can we have acid and it is equal?
Alkali.
Alkali is base. So that one done already. No, it's not.
Water.
Water is not equal. Water with the titration. That's so today.
Equal sodium carbonate.
That's an example of what we're going to say. Very good. Your soluble carbonate solutions. Okay, soluble carbonate, like sodium carbonate, ammonium carbonate. There's some carbonate that are dissolvable one, remember? Soluble in water. So this kind of titrations. So ladies and gentlemen, in general, there are many, many, many types of titration. For O levels, I believe these are the max that they will test you. So basically, when I enter the lab, so what the burette is there, right? I enter, wow, shit, man, burette is there. Imagine in my head is ding, 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 these three. One of you must come out. Okay? All right. Okay. What else? Done, okay, speed of reaction, everyone know already, right? Speed of reaction. So basically, conduct an experiment to measure something, right? What can you measure? All right. So you usually see what speed of reaction. You will always see what I call stopwatch. All those that are in our regular class, we just discussed this topic division, right? You always see a stopwatch. Okay. And what are you going to measure? So these stopwatch obviously measure the time. Make sense? So this measure the time. This measure the time in seconds, usually. And then you need to measure something that can measure. So some quantities. The common one in chemistry, physics student measure distance in terms of speed of reaction. We don't have distance to measure. We never use length on. So to us, it's always temperature, volume. No, they say length cannot. So be very careful. Okay? Mass or time management. All right, time management we all know, but mass. How can they do this? Very unlikely, but I don't know. Anyhow, okay, I have never personally conducted experiment. Maybe they have a strip of something. They ask you to put into something. They ask you to react. Maybe dissolve for a while. Maybe 10 seconds, take it out. Then maybe it becomes shorter or smaller or whatever. I don't know. Make sense? Then they ask you later, take another different strip. Maybe. Never seen before. Right? So you put it there. Then maybe this strip is become shorter. So the rate reaction between whatever is inside the beaker and my black color strip should be faster. The rate is faster. Blah, 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 blah. Okay? All common sense. So again, then I say, oh, you seldom, but never know. But the rest of quantity are more obvious, right? More obvious because we've seen it. Separation technique as a hands-on, I think is not very, I don't know, likely. I think it's more for planning. Simple chromatography. I'm going to ask everyone. Anyone here do simple chromatography in one practical experiment before, in Sec 3 to Sec 4? Anyone? Okay, 1, 2, 3, not many, 4, 5, okay, 6, 7, 8, okay, total of 44. Can or not? Again, I don't know, but I think planning has a higher chance. The whole question, design a plan whereby you use simple paper chromatography to decide whether a sweet is toxic or not. Later we discuss. I think they want it tomorrow. But if they ask you to conduct a real one, hands-on, do you know what to do? Okay, so you must go revise a bit. Okay, so again, filtration, distillation, right? That part. Distillation can't be lah. Distillation need distillation column. Everyone distillation column, everyone break one, then repeat the second one, MOE going to get in trouble. Make sense? All right, can't be lah. But planning can come out. Hands-on, unlikely. Salt preparation. Anyone spend an entire practical session in your school? Actually have once to make this salt before now. Yes, blue color, copper 2 sulfate. Yes, can till now haven't come out before, but you never know as a hands-on. Okay, so recollect back what you need to do, but they'll give the procedure, so you need to follow very closely. All right, but you must prepare yourself before we go in and read the procedure. Hope you agree. This again, I think more like a planning question. Well, this planning are damn good. It's like theory paper, just throw in. Okay. What else? Gas collection. Ladies and gentlemen, what are the few gas collection method? If you can't even give me the name, means you are in a bit of trouble. Come. Anyone tap on? Here, I got name. Good. Redox method, planning theory. Come on, anyone? Gas collection. How you collect gas? Water displacement technique. So how we use them? Again, this was the earlier topics that we learned in Sec 1, Sec 1, Sec 3. Water displacement method. What else? Upward, downward. All right. What do we call them? Usually upward and downward delivery. Usually, again, I follow what the syllabus call it in the reference textbook. They normally call it delivery, but some school call it some other words, I believe. Okay. All right. Delivery. Okay. So these are the gas collection. Don't forget, there's one more way to collect the gas. Don't forget about this one, last one. The gas syringe. One of the favorite question out of nowhere theory-wise, right? They will ask you, why gas syringe is not so good and can't be used for collection of gases in all kind of chemical experiment. You understand my question now? So when you learn collection of gases, very early in the Sec 3 called experimental techniques, we only show you these 3 techniques, 1, 2, and 3. Agree with me? Then out of nowhere, they will say, hey, gas syringe also can use. But it was not shown there one. Why? Why this one we don't really write it out? Anyone? Gas syringe has a limitation. What is that limitation for 1 mark? So these are all the theory questions. Do you realize that? What's the limitation? You all seen a great gas syringe before in your school? Can be compressed. Can be compressed. So I let the gas compress. Push it on. No, you the gas coming into the gas syringe, you shift the plunger, so it's okay. Cannot identify gas. It's about collecting the gas. We don't need to identify. Capacity. How big has you seen a gas syringe? Can't be this big, right? Try not. Ladies and gentlemen, the gas syringe always quite small one. All right, so it has capacity limitation. Usually, this is for small volume of gases. All right, the limitation is capacity. All right, small volume of gases can be collected using gas syringe. Okay, 610, there are a few versions. Okay, here we go. Then what? Then displacement reaction. I've discussed it, metal displacement, halogen displacement. I also discussed test for oxidizing and reducing agent. Since we are here, why not? Let's finish it. Recap. That will help you with theory. You want to test for an oxidizing agent. Make sense? So you use, okay, let me use the color, right? So you want to test for an oxidizing agent. So you'll be using a what agent? You use a, wrong color, use a reducing agent. And if you want to test for reducing agent, you will then use a or an oxidizing agent. For O-level students, your reducing agent and oxidizing agent in the lab is quite limited in terms of choices, which is good. What is the common reducing agent that you have in your lab that you use? Don't you realize it's all theory? Once you go in, do, finish, get the 2 marks after that. Jialat. I use English, by the way, dialect. In gone case really. Because they ask you all the theory question. Take a look at all the practical paper. Make sense? Half the paper is theory. Probably more than half. All right. What is that? K plus, potassium iodide. All right. You use your potassium. Can I just write chemical formula? Okay. Potassium iodide itself get oxidized. Okay. So must prepare slowly. I'm going slowly. Later, I'll go faster. All right. Let me warm you up first. Still quite cold. Okay. Then, what is that one and only oxidizing agent in O-level they use? This is called your... Thank you. It must have acids inside there. Acidified potassium manganate. That's why in the procedure, they will ask you add some sulfuric acid usually. Add some acid inside there. All right, I'll cover acid and then put in a K-manifold, then let them use it for testing. Or maybe they prepare for you already. All right, it's already acidified condition. Okay, done. So at least we are quite clear about this. Good. Lucas, K2Cl2O7 is not in syllabus anymore. In case your teacher never tell you, it's carcinogenic also. It's out of syllabus. But it's okay to learn that extra. Right? Nothing wrong. But you will never come out for a practical because it causes cancer. They will never let your parents sue the ministry. Okay? For your information. You can Google. Okay, all right. So these are all you need to know for O-level students. Okay. QA wise, you know all about that. Okay, here we go. Now QA, there is a lot of cations, a lot of anion, a lot of cations. O-level students, do you remember? My own students obviously know the number, hopefully. How many cations you need to know? Then you say, never mind, Mr. Chua, the table is there, I can just refer. Nothing wrong. Then paper 1, paper 2, haven't memorized. Prelim over, haven't memorized. Very funny, Yeah. How many cations? Total? 8. Okay. Anions, Anions of 6, man? I don't think so. Anions, I think there's only 5. Gases is then 6. I remember number is 856. Cat and gases. Again, to be verified, obviously, all right? 5 or 6 thing, familiarize, okay? So I won't write out the ions, that's boring for us, okay? Now, one of the cations that is that we know, all right, of the 8, right? The cation is Pb2 plus. Okay. You will not be required to carry out tests involving Pb2 plus. As well for the gases, all right, the 6 of them, sulfur dioxide also won't. Why? Once again, because they're toxic. So you're not supposed to handle them. Which means, you know what I'm saying? When you do a practical, you do your QA. Then suddenly, you smell something pungent, correct? You smell pungent. Right? About pungent gas, so you pungent. But right, pungent, if you know your gases very well, you have 3 identity or possibility. It can be ammonia gas, it can be chlorine gas, it can be sulfur dioxide gas. Theory paper, you need to know this. Paper 1, paper 3. I mean paper 2. Yeah. But what? But I'm very sure that this will not be tested. Wrong color. This color not strong enough. It's strong color, pink. This will never, if you ever smell it, it will never be this. Okay? Can't be because it's toxic. And they say they won't be, no need to carry out tests to do this. They will never set a question to let you test for the sulfur dioxide gas. So never ever put sulfur dioxide as the answer. Understand? And actually, I think chlorine also very unlikely because chlorine gas not good for when you inhale it also. So every time I smell pungent, right, I'm actually very sure close to 100% of the time is ammonia. Impractical. Everyone okay? Make sense, huh? Because I want to catch what SEAB provide for me, which is this page. Yeah. In a way, yes. So you minus, you know which are the ones. Okay, here we go. Reaction involving ions not included in the QA. So is it always that a few ions inside there? SEAB say reaction involving ions not included in the tables, unfortunately, may also be tested. In your school, you should have done it a few rounds of this already. And in such cases, candidates will not be expected to identify the ions because you have no color change or whatever to identify. All right? But you're supposed to just draw conclusion of a general nature. Okay? So I think we might have a question to look at it later today, right? On this one. I mean tonight. Okay, I think that's about all on this part. So I'm going to go to the big analysis. Minus CL2 and SO2, correct? The gas, correct. Yeah, here we go.